Okay, here's another rational inequality. It's actually a quadratic over a quadratic. And like I said in the last part, you don't really want to have to graph every one of these problems. As a matter of fact, this one's going to it's going to cross the horizontal asymptote, so it's going to be a lot of things you would have to actually do to do the graph. So we're going to try to do as least work as possible. So remember the three things that are important over rational inequalities: the vertical asymptotes, the x-intercepts, and the end behavior found by the horizontal asymptote. So let's do that one here. The first thing you're going to do is factor the top, and that's going to find your x-intercepts. So it'd be 2x and 5 and 1 minus 5x plus 2x is a negative 3x. And well, what if it doesn't factor? Well, the problems get a whole lot tougher when they don't factor. And every one of your problems will factor, so you won't have to be faced with using the quadratic formula to find x-intercepts when you're doing this. It's hard enough to do it we could make these problems a lot tougher than we do by making something that doesn't factor. And you'd have to end up using a quadratic formula, which would be kind of cruel and unusual punishment because it's hard enough as it is. And so we want to make sure these things factor. So if you're sitting there struggling with factoring them, you're just not, and you say, well, I'm going to use a quadratic formula. Before you get all angry, just remember what I just said. These all should factor. So x squared minus 4 is x minus 2 times x plus 2, okay, greater than 0. So now, remember I said you had to find x-intercepts, which is set the top equal to 0, and find the vertical asymptotes 2 and negative 2. So this one's going to have quite a few points on my number line. There's going to be 2, well, negative 2 and 2, so I'm putting 2 on this side, save some room. Negative 2 and 2, those are my vertical asymptotes. X-intercepts are 5 halves, which is 2.5, which is just on the right side of 2, and negative 1, which is between the negative 2 and positive 2, so negative 1 goes there. So, like I said, they don't have to be drawn to scale too great. It just have to be from the smallest to the largest. And I think negative 2 is smaller than negative 1, which is smaller than 2, which is smaller than 5.5 halves, which is 2.5. So I got the order the right way. Okay, and these are all odd degreed. Okay, so they're going to cross at the x-intercepts, so at 5 halves and negative 1, and at the vertical asymptotes it goes from opposite sides. So I'm just going to say cross. It goes from one side to the other. So they go from one side to the other on all of those points. There's no even degree on this one. Now, again, like I said on the last part, some teachers will teach it as if testing the points between each region. If you notice, it's 1, 2, 3, 4, 5 regions, and that means 5 test points if you do it that way. Some people will just do 1 test point and then using the C. The problem with that, though, is if you test this point wrong, put a number over here like negative 3, and if it's wrong, and if it was above and you're supposed to be below, then you're going to miss the rest of them too. So because all hinges on the first one that you do. I try to do without much calculations, and I look at the end behavior, and that's the horizontal asymptote. That's what I'm saying: vertical asymptotes, x-intercepts, and the end behavior. Those are the 3 things that are important when you're doing these inequalities. So in this case, this is degree 2, this is degree 2, so it's the leading coefficients of the horizontal asymptote is y equals 2 divided by 1. So 2 is above the x-axis. So it's above here at this end, and it's above at this end. So all the C's represent, they just cross over. So from here, it goes back down here, and then it goes back up, and it goes back down, and look at there, it goes back up to where it's supposed to be. So it's up, down, and up. Okay, so now it's not a polynomial, so it doesn't look like this. It doesn't have this polynomial shape. Okay, actually, it's at the negative 2 and positive 2, the vertical asymptotes. But we don't really care about the shape anyway. We just want to know where it's above and where it's below. Okay, in this case, we want the above because it's greater than 0. So the answer is going to be between negative infinity to negative 2. That's where it's above. Negative 2 to 1 is below, so we want that one. Negative 1 to 2, it's above. 2 to 5 halves is below. And then 5 halves to infinity is above on this side. Okay, no brackets because it says strictly greater than 0. So there's three intervals where this thing is greater than 0. And you're like, well, why so many? Well, you got a couple of vertical asymptotes on top of this. So there's 4 places total where it goes from up, down, So it's not surprising that you have three intervals where it's greater than 0. As a matter of fact, you're going to have two intervals that's below 0. So, and I got one more to do show you there that's kind of different from anything you have seen. I've done some of these in class, one or two of these in class, but the next one I'm going to show you is kind of in a league of its own. That's the next part though.